Um, I don't know if I can advance this from here. Um, so, there we go. So, something strange started to happen. I spent 2 days in Barcelona before coming here, and everywhere I looked, this was my hotel room, and instead of giving me a bed, they give me this hammock, and I'm, like, what's going on? And everywhere I've been, it's like I'm preparing for this event. It's been just amazing. And then I go, the image on the right, I'm not sure who he is, but it kind of encapsulates everything that I was hoping the fabrication workshop would be about, kind of mixing skin and structure and things like that. And then I go to Tapies, to the museum, the foundation, and the paintings are starting to look like things that I imagined we're going to make, and it's just been incredible. So then I go to the Design Museum in Barcelona, and again, these things are there, and this is kind of what we're going to do. And everywhere I went, it was like Spain was telling me, look at this. So it's been just incredible. So I want to share with you just some of like my beginnings to give you some context. So I had an opportunity, if I can figure out how to do this laser, there it is, to study under Tadao Ando at Harvard at the GSD, and he was a professor there. It was one of the few times that he's taught in the United States. And after that was over, he invited me to go to Japan, and I didn't have any money to go. And I was very lucky. There was a traveling scholarship or fellowship that year, and I was able to get it. So I spent a year as a researcher in his office and looked at all his work, and had a sort of desk to study in his office. But then along the way, I started to meet also artists in Tokyo and Osaka. And I met this woman. I don't know if you can see this photograph very well. It's kind of dark. But her name was Naomi Seki. And I was just incredibly impressed with the way she worked with materials. And I'd never seen anything like that before. And so I said, look, I don't know how I'm going to do this, but I'm going to invite you to Boston to do a joint installation and to show your work. So this was the first group of students that I started working with back in 1993 in a design studio where we mixed drawing and regular sort of design with full-scale making, and I've never stopped. I've been doing this ever since. And then the guy here with a little bit more hair, that's me. And then, I could tell you stories about each one of them. So that's kind of the beginnings of where these kinds of things, these kinds of workshops and the type of studio that I've been teaching, that's kind of where they came from. I couldn't really think of a better word for this, so I think somewhere the word monster came up. So I thought it would be fun to talk about monstros, and maybe there's a lecture or something that I do on monsters. But these are just some quick images that I sent over in preparation for the workshop. The one on the left here, many years ago, one of my students in Arizona built this little model, and on the outside is a exoskeleton structure, and then it's pulling, the interior surface is pulling on that structure. And what was really interesting was only about this big, but I've always remembered it. They were kind of codependent. The skeleton would fall down without the membrane, and the membrane would not stay up without the exoskeleton. And then the work of Sean Alquist is this image here. He's teaching in Michigan. He does amazing tensile structures, and then he codes all of he does meshes in Rhino, and he uses, not even in Rhino, he does it in pure code and processing, and then he adds the gravity force and watches it fall. So he came and did a workshop with us. This is Tomas Saraceno's work, and somebody did a pavilion that, I don't know, it's not really like what we did, but so these were some images that I sent over to kind of get the conversation started. And again, these are pavilions that I've done with my students. This is one in Houston. We did use polycarbonate to set up a shell structure. But the reason I wanted to show this image is because the way I introduce, at least the way I think about things, is that we don't necessarily have to start with a form, that you can start with the module or element, and then you can just learn the rules for how to combine that little element, like a piece of paper, that's folded into a much more complex module, still not knowing what the form is going to be. And this is the way nature kind of makes things, right? And then that module, they start combining and combining with some rules and end up with something much more complex. So that's been kind of the theme of a lot of the things that have been going on. And I'm just showing you a few images, not a lot, of prior work with my students in Arkansas because they inspired kind of what I wanted to do here. And so I had a student named Blake Leonard, and he was making like speakers for putting in your car when there's a game and to have like music in the parking lot. And I said, what is that? And he told me. So we started coating fabric, stretch fabric that can stretch in two directions with resin. And then you could pull these points and create complex shapes. But then it always ended up in these points. Then we figured out that you could go to the laser cutter and you could laser cut a shape. And now that's very important because now you can start a conversation between the digital and the physical. So that's the other theme, is this conversation between the digital and physical, to be able to calibrate material, take it back into the simulation environment, or to produce work that might transfer well to specific material systems. And here he is just working with a frame and beginning to create this kind of network tube structure with the laser cut plates and with this little one, which is the one that he started with. And then the other one that I've shown a lot is this sort of bone piece that he made, which are just flat pieces of fabric. They weren't hard at all. And then with the resin making them quite hard, and sort of the final piece. Then, right before coming over here, my current students were just sort of throwing some things together so that I could figure out how to set up the workshop here. And really it became a conversation between the line of the string or the rope and the surface with the stretch fabric. And then I made a quick test to see how we were going to set this up, which is really to begin tensing the fabric in a sort of vector so you can create a volumetric shape that can then be hardened with this mineral and resin mixture, and then be able to turn it into compression structure. So that's kind of some of the background. So pretty much the first day was crazy. We didn't know what we were doing. We grabbed the chairs in the classroom and just said, let's use these. So we turned them upside down and started like a spider, weaving thread. And then I said, go to the bathroom and run and get some paper and let's wet it so we can see the surface. And then we opened up the material that we're working with and we made our first test, which is this kind of pulling on the fabric and then painting it with the material. And in 20 minutes it was hard, very, very hard. And we knew it would work and that we could use it. So that was kind of the crazy first day of just trying to understand what would happen with these materials. And here you can see it's just like back in the Fab Lab in Arkansas where I had tried that test. It's a very similar shape by just pulling on the material and keeping it tense and then creating this shell. So with that, we thought, okay, no problem. Let's keep going and we'll create beautiful work. Now, a lot happened in between, and I'm sort of jumping to the finished product. I think one of our, Matthias is here, he gave me a flash drive with some digital images, and I haven't even looked at it, but I have it on here. We had some time when we were kind of trying to figure out if we would do this in a parametric software, and if some of you don't know what that means, hopefully you all do, but that we could actually control very accurately, and also using the force of gravity to simulate the way that the surface would deflect. We could kind of control all of that and simulate it in an environment, in a digital environment, before spending the time and effort and the material that we only had a limited amount. So the first few days, or one day really, we gave 3 different groups the challenge of just taking the material with different colors, picking a different part in the building, and seeing what they could make, and with some sort of rules. And with this idea that we would take the points and pull them, but then maybe we would get more specific about the way the fabric is formed. And the first group picked this sort of passageway that also, it serves 2 purposes, placing it here. One, is that it becomes like a mural, and when you're sitting in the classroom, you can see the elevation of it. It's very beautiful, but it also begins to activate the space that you can sort of walk through here and begin to develop a sort of volumetric and spatial field with the fabric. So this was just for our students to become confident working with the material. Here you can see we've transferred from pulling points to beginning to shape the pull so that we can create these kind of funnels and voids and then later harden it and so on. So this was just kind of to become sort of familiar. And these are way out of, these are like totally out of sequence. I just threw them in, so I apologize. And we'll jump back to some of the other ones. In fact, let me see if I can do that. Yeah. So this is the second one. So the first one was sort of the backdrop of the classroom, and it's also kind of a secret passageway. This one is the ramp. And so we started kind of covering the ramp and seeing what we can do with the network of fabric to turn it from just a skin to a kind of volumetric thing. And again, I apologize. So these are out of order. I'm going to come back to this. Then we thought, okay, this is much later. After we went through those first phases, and the next question was, how do we begin using this material as not so much just a soft, stretched fabric, but can we begin thinking of a surface structure, surface active vectors, where you're beginning to think about maybe transferring from a tension system to a compression system, and to see if the material would be strong enough and if the resin mixture would work, and then applying a sort of geometric rule. So what we did is for this piece, we hung it in the courtyard, and then we started both pushing the fabric out, but then also pinning it back in. So you have expansion and compression laterally to create a kind of strength and patterning in the skin, to then come back and coat both sides of it. And the intent on this was we were hoping that we could actually detach it and place it so it could carry its own weight. So this is quite far, actually. This was today into the project after we had done all of these others. Here you can see it's liquid resin, and then it's a mineral powder, and we mix it in the correct proportions. So another project that we did, there was in conversation with the professors here, we started to talk about the possibility of creating an acoustic shell or acoustic kind of environment where you could maybe place something in there and listen to the sound, because the qualities of the hardening of the material creates a beautiful kind of resonance. So in order to do that, we really had to create a piece that would be large enough for us to get inside and to listen. And so it's quite, maybe 1.5 meters or 2 meters. To strengthen that and to create a surface that could sort of hold itself would be difficult. So this is all happening, learning with your hands. So all of this is what the theorist Michael Polanyi calls tacit learning, which is, it's not about making the plan and the drawing and hoping that you have it all completely figured out. It's getting out there and just seeing what works and learning with your hands. And so this kind of design and making has been the constant theme. And we just placed these pieces to push and create a sort of micro pattern in the skin so that the corrugation of the skin would then help it to sustain the weight. And here, then we had a structural engineer make the first test and hold up the canopy, right? This is the final piece. And so what you can see with this one, as opposed to the others, is it's not respecting the lines of force. It's not sort of respecting what the material wants to do. It's respecting what the architect wants to do. So the other theme that came out in the workshop was that there's two conversations going. There's the desire of the architect, and then there's the desire of the material. And it kind of works back and forth. And I think when you have a good architecture is when you listen to your dreams and what you want. You listen to the client, but you also listen to the material and you understand what the material wants to do. And if all of that is in balance, then everything works great. So this was the last one that we did, which was to try to create a kind of spatial environment or shell with this process. And then we went on a journey, and we finally said, okay, we're going to take this, and it's like Don Quixote or something, I don't know, it's like traveling across Spain. And so we took it across the campus to the music school, and this is a whole other story of what happened here that we'll share with you. But so that was kind of the trajectory of the week, which was going from initial studies, trying to understand the material, doing a few experiments, and then quickly testing the material, the resin and the hardener to see if we can come up with a rigid shell. So I can tell you a little bit about, okay, and here you can see the other large piece with the push and pull on the membrane, and you know, it has a lot of weight. So we learned a lot. So this is all about empirical testing. And we learned that we really need to apply many more coats of the resin, that we need to study oriented fibers. So if you add fiberglass, glass fibers, and you begin to orient them, and so then we could create a much stronger panel. But the difference with this one and the ones we did before is that now here's a regular grid and a regular order, and it's almost like a Jean Prouvé panel or something, but trying to do it out of the soft material instead of a rigid material, and yet still allowing the conversation to continue, the tensile conversation of what the way the material wants to behave, but now imposing a kind of order on the material from outside as well. The other aspect of this project, I don't know if I'll have time to show you some of the digital files that Matthias, one of the students, prepared, which are amazing. So here's what happens: the digital models get way ahead of our material knowledge, and then they persuade you to want to do something that you do not yet know how to do physically. So this conversation also works across that way. So here's a setup, much like the Gaudí, inverted shell, the hanging chain model. So one of the things that I do with the students is I prepare a comprehensive design tool. It's completely parametric. It has physical forces already in it. So I came and I gave this to the students, and the idea was to begin understanding the digital modeling process. Not only allows you, the parametric process, not only allows you to quickly iterate and make different forms, but this is adding gravity. It's changing the shape according to external forces. It's labeling all of the panels, so if we were to make this in a laser cutter or CNC environment, it would automatically allow you to see each panel as you select it, and then giving you all of the shapes. This is done all the time. I think what is new about this example is that we're combining that old way of doing the surface division and sending it to the laser cutter and so on. This is all live with the Kangaroo, with a software that allows the live forces to interact with the model at the same time that you're getting all the data for the fabrication. So, having a live model that's giving you data for the area, the cost, just everything, as you're able to flex and move the model, a kind of customized building information modeling, but instead of using like something you buy like Revit, or to create our own environment through using the Rhino and Grasshopper software. Okay? Okay. So, some thoughts about why I do this. This is a wonderful little book by Kieran and Timberlake, architects there in Philadelphia. And they wrote this little book called Refabricating Architecture. And they're saying that we need to bring back the tradition of design and making, just constantly going back and forth, and not having one person who designs and then you send the fabrication order to somebody else and they make it. Of course, we can't make buildings that way. architects are designers, but to learn from materials directly. So their office I don't have a photograph, their office in Philadelphia has a huge space inside. And when they're working on real projects, professional projects, at the same time, they're doing research and development of new systems and materials in their practice at full scale and doing amazing experiments. And so they've taken this philosophy from academia to the professional world. And they're one of the few examples that I know. The only other one I know would be Jean Prouvé back in the 1950s and 60s, who was constructing everything as well. So to me, that's a big deal, that the notion of the architect and builder, the product engineer, the material scientist, that you bring all those things together again, like Brunelleschi or someone like that understood the entire fabrication and design workflow. Another concept is that we think in terms of objects. We think in terms of singular objects when we design. But there's also the idea that an object is made out of many parts and pieces and components. We tend to, as architects, to depend on a catalog and to go and select everything for our buildings. The other way is to think of it at a more social level, not the architect and then the selection or the design and the singular vision, but it's a collective, like these ladies here making the quilt. And so it's two different things. It's the master controller versus the simultaneous feedback that you get by working together. So behind all of this story, there's a kind of social model that is implied, which is to develop a collaborative practice. Okay? Where does this come from? It comes from nature. The idea of, this is a cactus from Arizona that I've been carrying for many years. And what I love about it is you look at the form. It's a very tall, thin cactus that can grow without falling over. And it's only about that round. And it has this sort of diagrid pattern. But then when you look more closely at the fine grain, if we could see this more clearly, you would see this exact same pattern at the micro scale. So nature is very economical with materials, but also with the rules that nature applies to make things. The same rule at one scale, then another, and that was the beauty of this. So I'm not going to go through that. I'm going to skip a few of these slides. The research, this research that we've done here will get published, and I'm really looking forward to it. And so a lot of these are the same conversation, the algorithmic or digital, and then going back to the material process. And that's really been the theme of the work over many years, which is shown here. Okay, so a new aspect of this work that we didn't do this week, but that I think is very important. How can we embed, an awareness of the environment, both locally with cold or warmth, but also globally with climate change? How can we begin thinking about digital fabrication and design and the way we make things, but also embedding a kind of sensing the change in our environment, both the local and... So this is the next step, but I just wanted to share it with you. This is going to be a robot stick-built sort of tower, but the idea is that there's sensors, moisture, pressure, wind, and all of that information is going to affect the robot and also the final form and how these sticks are placed. So the idea is to deform the geometry by blowing on the wind sensor, or to have the structure inflate because it's getting warmer. So in the process of making that, it's not just our direct desire that we begin to have a conversation with the environment. Okay, so that's another theme that's going to develop. I'll skip over this. This is from practicing, and so it's kind of my own work. Finally, the teaching model that I like to employ is drawing to making. So drawing to making seminar. Whether you're drawing by hand or you're writing code, this is processing and then creating patterns, but really beginning to understand the structure of things through drawing, cutting the vegetable and understanding the structure, or making something after you've drawn the bark of the tree to actually then write the code, and this is not a good example, but that would understand the structure of the bark and so on. So this seminar takes the entire workflow from hand drawing to coding to the grasshopper, and then finally to have some physical, tangible thing in your hand, or like a chair or something that you can sit in. So taking the entire workflow and using that to design. So about a year ago, I was approached by there's a new museum in Arkansas. It's called the Crystal Bridges Museum of American Art. And they bought a Frank Lloyd Wright house, a Usonian house, in New Jersey on the east coast of the United States. They took every little piece apart, they numbered it, they put it on a truck, and they took it, it's like from here to Madrid or something, or maybe further, and they rebuilt the Frank Lloyd Wright house. And so then they asked the School of Architecture, we need something to explain to the public who is Frank Lloyd Wright and what did he do. So they approached me and my students, and we spent a year. We designed and did the construction drawings, but we fabricated everything in this pavilion, and we prefabricated it in the shed, and then took it to the site and built the pavilion. So this is mass customization. There's no right angles in here. Everything you're seeing is, these are CNC cut steel and wood that are behind this plastic. All of the geometry is curving and so on. So it's one thing to draw that and to know how to draw curve well. It's another to make a curve out of flat panels and steel, and then finally have it be like you had it in your model, that it's fluid and beautiful. So this was an amazing process with a lot of labor. And then the other thing we did is we took the patterning and applied the patterning from the leaves on the trees and so on, the Voronoi patterning. So this was a one-year-long project, and very, very intensive. So the reason I'm showing this is because it's probably one of the last projects that I'll do where it's completely dependent on labor, on a lot of human labor, because then the next step is to incorporate robotics. So you can see here the student is welding and cutting, TIG welding, cutting the metal, making each one of these panels by hand, understanding the angles from the digital model so that we could get the continuity of the steel panels, and just an incredible amount of labor, and then taking everything from the shed where we made the project, making sure it fit. We built it twice, once in the shed and then the second time on the site to make sure everything would fit. So that was the prefabrication, what I call design fab. And here you can see the diagrams from taking the patterning and then projecting it onto the surface. So it's a continuity of the same ideas going back from 1993 with Naomi Seki to the work that really I'm doing here this week. The second thing I wanted to show was this project, which is after spending a year on the museum pavilion, we then made this robotic pavilion in like 2 weeks or 3 weeks. So we programmed the robot to pick up sticks. You can see the students here, and create modules. I'll show you in just a second. There are no connectors in this project. The precision of the robot allows each stick to be placed so perfectly that you can then take each module, carry it outside where we built the pavilion, and they all mesh together perfectly. Okay, so there was no need for fasteners. So it's really the next theme. The other reason I'm showing this is because going from the soft to the hard material, like we're experimenting with this week, the idea of the hardware or the connector can go away. You can start to think of the way that nature makes things, where there's no need to like put a screw or a bolt. You create through the soft layering and application of material, you already embed the logic of the joint. So I think this was like a way to think about that, about the logic of the joint. And that's the finished product there in front. So this is where I have the Fab Lab. Very lonely, not like I've been here, with so many friends. And I'm by myself here all the time. And then it gets very busy when the students come. But this was all built in 2 weeks, very fast. And then here you can see the diagrams, going through the Rhino model and creating many variations until we decided which one we thought we could build. And then here you see the robot in my lab, and it's got a stick. It has to choose. It has 3 different lengths of sticks, the short ones, the medium ones, and the long ones. So it goes and picks up the correct one. Here you can see the sequencing, and this is the motion path that the robot has to take to place each stick. And of course the sequence is important because if you tell it the wrong thing and these are not there yet, it's going to come over here and put a stick and then drop it, and there's nothing there to hold it. So you have to change your thinking when you do this from geometry to choreography, how things move and the trajectory and space of the robot. So you have to completely take the data from the Rhino model and rebuild it now, not in terms of geometry, but in terms of the way the robot is going to move in space to create the first module and the second and the third and so on. And then as we take these out and remove them, we're ready to make the next one. So it takes about 30 minutes to stack the sticks, and we have a module. So it was very, very fast. I'm not going to show you all of this work. I'm going to just flash through it because I want to get back to our pavilion here and show some of the digital studies that we ended up with. But you can see in all of the classes that I teach, this is the regular third-year undergraduate studio, and we do regular drawings and models, but then also I try to do what we did here this week of working full scale with materials. This is in the hallway. We didn't have a Fab Lab when I did this. We didn't have anything really, just like a drill and a couple things. And then these are all the things that 40 students did for this project. So going back and forth between the regular kind of design studio environment and the small models is very important, and then understanding the logic of those materials on the design through actually making it at full scale and having that feedback from one to the other. And there's some more. Here we're structurally loading it, and we had a great day when we broke these, and everybody's yelling. And so to see how light we could make the skin, and then how heavy, how much weight it could take. Okay. How much time do I have? It's a good time? Yeah, okay. Again, it's all about logic and emotion, or intuition and logic. The emotional side, the love of materials, but also to have a rule, to have something that repeats and allows you to work in a disciplined way. So this is just string and a very thin board, and then tied together to create this sort of parametric logic. Other examples. So today we were talking about when I was introduced, that what we take away from this week is not whether the final form was able to achieve the goals that we had, which were quite ambitious, or not. It's what can you do next. This is a flat pack, completely parametric model was used for this. So if we change the form, all of the joints would change as well. And Akihiro Yoneda, who's a student that did this, he's now working for Kengo Kuma in Japan. And I'm not the only one responsible for that, but this project has really did a lot for him. And what he did is there's no tools needed to put this together. You just press the tabs and everything is flat, comes off the laser cutter, and there's no tools at all that were used for this. It just fits together and snaps and then creates the form. Okay. And then after he did that, he wanted to learn how to weld. And so here's the parametric model. It gives you all of the joints and all of the shapes. and he creates the tower. Okay? And the rest, there's a lot more on here that I can show you. These are from Houston, and so we wanted to work with the wind. These big structures, the wind comes through here and accelerates. So we wanted to create a structure that allowed you to see the wind, right? And then the material that we used was bent plywood. And here you can see the scale. One panel is about the size of a person, and they're vacuum forming it, and then creating all of the joints and all of the bent laminated wood to then have this kind of cloud that goes out into the landscape and can be a kind of visual experience of the wind. And if you go and stand there on a cold day, the Venturi effect is enormous. I mean, the wind just... So we wanted to visualize the wind. A couple more projects where this was a studio together with William Massey, who's up in Cranbrook, to look at systems that can be modular, that can be both welded and bolted, so that you can take the components to the museum or to the site where it's going to be assembled. So you're working with what the little red book of refabricating architecture, that book talks about making things the way they make ships now, where they chunk the modules and it's not dependent on gravity. So the way we've made things this week is gravity dependent, right? Completely gravity dependent. But there's another way to make things, which is he calls chunking, which is the way they make supertankers, where you don't have to wait for gravity. You just make things, and then you bring them together, which is what we did here inside the lab. Finally, I think this is the last one I wanted to show you. So the work we've been doing this week has been inspired by a student that I had back in 2005. He was going to do his thesis, and he came to me and said, "Professor, I'm going to take $10,000 of my own money, and I'm going to make my thesis in my backyard in my house." Okay? And so it was a lot of trust. And there he is, that's Brian. And so he didn't know how to work with these materials. We had been out to the desert, and they had seen the cactus. He came back and did the laser cut models and so on. And this is the rendering of what he wanted to make. Something which had a beautiful fiberglass skin, kind of like what we made here today. And he wanted it to open and all of this. So you can see he's working with wooden panels, but trying to make a compound curve, and that's very hard. Then he worked with metal and discovered that metal, when you try to make a compound curve, what happens with metal? It buckles, and it doesn't want to stay smooth. And so he learned that. And then finally, he worked with latex rubber, and this was in Miami. And what do you think happened to the latex when it got hot? All the connections started to get soft. And so working directly with these three materials, he got the knowledge and the confidence he needed, and he started building his thesis. And then he wanted to apply the fiberglass. And I don't know if I should tell you the story of what happened with this. Let's just say that we let him graduate. And he got far enough along with the project that he had control of the material logic and the material system that he was investigating. So it was a great success because, he started with the models, he understood the materials, and finally working with CNC ribs in full scale. Okay, I think that's it. I want to leave time to show Matthias digital. So I don't know what's on that flash drive, but I'm going to open it up and look. So if you have anything on there I shouldn't see, Okay, so let's see. Let's see, Matthias. Where do I find it, Matthias? Alicante? Because I want to show your digital images. I don't see it. Here? Okay. All right, and these are the ones? Okay, so let's... So I wanted to show you his work. So we did not really have the time to combine the digital. Even though I prepared the model and I thought I would get here and hand it off to the students, in 1 week it's impossible. You either have to choose digital or physical. So an ideal way to do this is we would have spent the first week doing the digital and preparing really well the plan for what we're going to do. And then the second week you take the digital models and transform them into the digital. So what I did is I said, okay, let's pick 1 or 2 students who are only going to work with digital while everyone else works with the physical. So Mateus did these beautiful things. And what I'd like to ask you is which ones are purely geometric or topological, that you only used your modeling skill, or did you use kangaroo for some of them to apply gravity and force? I think the answer is you only used the geometric version. I don't know.
These ones are more handmade.
Yes.
I only use a script that simulates the way...
the relaxing of the mesh. Yes. 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 So he's working with a family of surfaces called minimal surfaces. They come from mathematics, triply periodic minimal surfaces. And they're like the soap bubbles. The equilibrium of the force on both sides of the film allows it to not pop or not tear or not break. And then how do you work with those forms and not so much the shape that you want, but maintaining the equilibrium in the surface, and then working in an additive way where we can have many, many modules and combining them to create this sort of complexity. So this is what you've been investigating during the week. And these are some of the images that came out of that. So the work that we showed at the beginning with the hanging skin, this is what we would continue to do and to make with multiple modules. Now with much, if you remember the bright orange and green panels at the beginning, but now taking that, and the first time we did it, it was with intuition. It was with not so much with the logic of ordered rule, but looking at the space, looking at the passageway or the ramp, and then beginning to work with material. So this suggests another way of working, is that you have a kind of ordered lattice or grid, but you're always having also that conversation with the stretching of the fabric and then working back and forth. I would love to continue this and for you to take this now and actually use the resin that we still have and the powder and make some of these modules, right? That would be the next step. Beautiful, beautiful work. So this has all been, this is the first time I see this. This has all been happening in parallel with our physical studies.
Those are made from a cube.
Yeah. So the way a lot of the geometry starts is very simple. It's inscribed within a cube, but then through going from the rectangle to a saddle, to a doubly curved saddle patch or shape, just like taking a little piece of paper and then bending it in 2 ways, then that becomes the module instead of the flat panel. And then that can develop much more complexity in the form. Am I going around and around, or are these new ones? Okay, beautiful. Now the last thing I want to show, if it works, I hope it works, is we went on a journey. So we decided that we wanted to take one of our projects on a kind of magic journey. And I hope I'm able to show it to you. And so before this plays, I'll just give you a little background. Hopefully it'll work. So I'm not a pianist. I don't have any suggestion that I, am a musician. I've never had any training in that. But my daughter likes, or she was supposed to take piano classes. And of course what happened is the piano's there, but she's not using it. So the piano stares at me every day when I go home. And after a while I thought, why don't I just try to play the piano, okay? Unfortunately, I made the mistake of mentioning this to Dr. Sanchez Medina, in which he immediately said, well, you're going to have to play when you come. So that's one story. The other one is that we wanted to see the behavior acoustically of these rigid shells, starting from the soft fabric and ending with the rigid shell. Well, no son muy portable. You know, we couldn't make the project portable. So what I'm going to show you now is the magic journey of the project from the School of Architecture to the School of Music. And hopefully this is going to show some of that, because I haven't actually seen it. Turn it up. There's only the sound? We need to see it. We need the technical help. We need to stop and see this. It's an MP4 file. He transferred it from his phone. And after that, I don't know. Why can't we see it? Ah, there we go. And can we increase the sound, make it louder? Yeah, there we go. Bueno, muchas gracias a ustedes.
Muy bien, un gran pianista, un gran pianista.
El pobre, el profesor del departamento de música, el pobre,
gracias, Santiago,
estaba...
por este taller, gracias. ¿Qué? ¿Hay que darle?
Sí, o si no, le doy este.
No, estaba, ¿no? Igual.
Déjame le doy este.
Tampoco voy a hablar mucho.
Mira, se lo doy aquí.
No, sí, igual, venga. Pues nada, quería dar las gracias por estar aquí, por este taller que has hecho. Gracias a Javier por haberlo traído. Estaba pensando mientras veía las imágenes que el título de esta conferencia, ¿no? Elastic Boundaries, límites elásticos, un poco vendría a ser como una metáfora material de lo que en este momento está sucediendo en la arquitectura, y es lo que está sucediendo entre todos nosotros los arquitectos, ¿no? Es decir, yéndose a una posición absolutamente simétrica y casi en el otro lado, digamos, de lo que tú has enseñado, todo lo que tenía que ver, digamos, esta mañana lo hablábamos con lo que nos ha enseñado Bruno Latour, o las esferas de Sloterdijk tendrían que ver con esta idea de que los límites, digamos, de nuestras posiciones, sobre todo de nuestras posiciones sociales y políticas, se han hecho transparentes, y seguramente esta sería una entre muchas maneras de encontrar una cierta correspondencia entre lo que son las posiciones ideológicas, políticas, culturales, etcétera, etcétera, y las posiciones materiales. O sea que tu conferencia es de lo más oportuno en este momento y esperamos que vuelvas.
Bueno, pues muchas gracias a ustedes.
Muy bien, muchas gracias. Y acto seguido vamos a hacer la entrega de los diplomas de aquellos que han participado en el taller. Así que, por favor, puede ir subiendo Juan Manuel López Carreño, Tamara Martínez Padilla, Tamara, Matías Germán Loisa. Carlos Ortiz Macía.
Aquí está Matías, ¿no?
Sí, pero aquí tienes a Juan Manuel. Matías. Matías.
Well done.
Very nice. Thank you.
Diana Granescu. Is Diana here? Yep, that is you.
Thank you. Careful, don't fall.
Thank you. Thank you very much. Mariana Marino. È Mariana Marino qui? Lidiana Donorio. Grazie mille. Thank you. Estupendo, nos hablamos.
Buenas tardes. No tengo la palabra para agradecerle. Me alegra mucho que por ahí estaba. Adiós.
Bravo, bravo. Grazie mille. Virginia Quílez.
Gracias.
Muy bien, Virginia. Buen trabajo. Kevin Marco.
Gracias por todo. Muy bien.
Y gracias por el DNI. Alberto Luis Bernabé.
Alberto, bien hecho, muchas gracias.
Sigues con la barba.
Sí, hola.
Karen Roda. Karen Roda.
¿Cuál era la cosa con la barba que sí?
Se afeitaba y se mantenía. Ahora por el PCC, a recuperar. Y por supuesto, está Karen, está Bora. Bora King. El PCC. Óscar Romero. Pascale Atzma, Cocodrile.
Thank you so much.
Pascal.
Parece un poquito like Arkansas.
Arkansas.
Yeah.
Angela Shepard. It's not here?
Angela.
Ah, sí.
Angela, gracias tanto. Muy bien hecho.
Eva Candela Delf.
Gracias tanto. Hey, no se nos olvide.
Vale.
To you, Delph. Okay.
Iqbal Sique. Salam alaikum. Okay?
Okay.
Then
Thank
in
you
that
so much.
case, egg, balsil. Egg, egg. Salam alaikum.
Yeah, okay, thank you.
David Martinez. Este es karateca, este es un arma blanca, de verdad. Es peligroso. Estás por tu tía.
Bueno, ¿foto? ¿No hay foto? Mamá, ¿tú una foto?
Aquí vamos a estar toda la tarde.
Ok. Marta Mokniak. Is from Poland.
Yeah. Wow.
Thank you, Marta. Thank you very much. Are you better? Do you feel better?
Yeah.
Thank you. And now a very special clap to Professor Daniel Carratala. Daniel Carratala, Gravity.
Why don't you should give him that one?
No, please. Bueno, muchas gracias a todos y me acabo de dar cuenta que ya hemos acabado. Gracias. Ahora fuera de micro. Fuera de micro me acabo de dar cuenta de que este señor os tiene que firmar todos los...